Hello everyone, I'm Gokul S from EC second year. I'm going to explain my case study in electromagnetic field. My topic is about classification of magnetic materials on the basics of magnetic moment. Let's see some introductions and classification of magnetic material. Magnetic materials. Magnetic materials are those materials in which a state of magnetization can be induced. In other words, the materials which can be magnetized are known as magnetic materials. And the other one is magnetic moment is a measure of the strength of a magnet. It is the product of strength, one of the poles, and the distance between the two poles of magnet. Classification of magnetic materials. Magnetic materials are classified into different characteristics based on the magnetic parameters, temperature, magnetic field, and magnetic properties. Let's see the different types of magnetic materials. Diamagnetic materials. Diamagnetic materials create an induced magnetic field in a direction opposite to an externally applied magnetic field. The permanent dipoles are absent in diamagnetic materials. They are repelled by the applied magnetic field. Some of the general properties of diamagnetic materials are: diamagnetic materials experience a repelling force when brought near to the pole of a strong magnet. The relative permittivity is always less than 1. Example: bismuth, copper, lead, zinc, etc. And the next one is paramagnetic material. Paramagnetic materials exhibit magnetism when the external magnetic field is applied. Paramagnetic materials lose magnetization in the absence of external applied magnetic field. These materials are weakly attracted towards the magnetic field. Some of the general properties of paramagnetic field are: these materials possess some permanent dipole moment which arises due to some unpaired electrons. Paramagnetic materials experience a feeble attractive force when brought near to the pole of magnet. Example: platinum, aluminum, copper, sulfate, etc. Let's see the next one, ferromagnetic material. It is a phenomenon in which a material gets magnetized to a very large extent in the presence of external field. The direction in which the material gets magnetized is the same as that of the external field. General properties of ferromagnetic materials are: ferromagnetic materials experience a very strong attractive force when brought near to the pole of the magnet. Permeability is very much greater than 1. Substitutability is positive and high. Example: copper, nitrogen, etc. Variation of substitutability with temperature in a ferromagnetic material. Next one is antiferromagnetic material. It is referred to the phenomenon in which the magnetic interaction between any two dipoles align themselves antiparallel to each other. Since all dipoles are equal magnitude, the net magnetization is 0. Some of the general properties of antiferromagnetic materials are: the opposite alignment of the adjacent dipoles due to an exchange interaction. Like ferromagnetic materials, antiferromagnetic materials also possess dipole moment due to spin-off electron. The susceptibility is very small and is positive. Variation of the susceptibility with temperature in antiferromagnetic material. And the last one is ferrimagnetic material. Ferrimagnetism is a phenomenon in which the magnetic interaction between any two dipoles align antiparallel to each other. But since the magnitude of the dipoles are not equal, the cancellation of magnetic moments become incomplete, resulting in a net magnetization in the material. Some general properties of ferrimagnetic materials are: ferrimagnetic materials possess magnetic dipoles moment due to the spin of the electron. A ferrimagnetic material is composed of more state of different transitional elements. The susceptibility is very large and positive. Example: nickel, ferrite, and ferrite. This diagram shows the variation of susceptibility with temperature of ferrimagnetic materials. And the final overview of dimagnetism, paramagnetism, ferromagnetism, antiferromagnetism, and ferrimagnetism. That's my case study of classification of magnetic materials on the basics of magnetic momentum. Thank you.